Okay, I think you're going to find this pretty easy to do today. So let's just read the very top sentence up there. It says two events are independent if knowing that one event has occurred does not change the probability that the second event has occurred. Now I know that does not make sense, but this is, let me give you a simpler version. So like let's say for example, let me give you an example of independent events. So if I have a coin and I have a die, right? Me flipping a coin and it landing on a heads would have nothing to do with tossing a die and getting a 5. So we consider those events independent. So in other words, if I land on a heads on a coin, it's not going to affect what number I roll on a die. Does that make sense to you? Okay, so they're independent of each other. They don't rely, the results of me tossing a coin has nothing to do with results of me rolling a die and getting a certain number on a die. All right, so you can see here that basically there are two rules for independence. The first one is using this formula right here. Okay, so the probability of A and B, that's your overlap, would equal the probability of A times the probability of B. Now there's a second independence rule as well, and it's the probability of A given B equals the probability of A. Now the way that I would tell you to use this one is, you see, if we look at this, right, see the first letter before the given symbol? That's the letter that you're going to see right here. So if there was the letter R right here, then we would have probability of R right there. And I'll show you how it works as we go through an example. All right, so let's look at number 16. We're going to do the even ones. So it says that there's an 8% chance that a person picked at random from the adult population is a regular smoker of cigarettes. So I'm just going to say the probability, of you being a smoker would be 8%, so we know that's 0.08, right? Okay. Then it says there's a 1.8% chance that a person picked has emphysema. So I'm going to say the probability that somebody has emphysema would be 1.8%, right? So then we know that that is 0.018. Okay. If the percent of the adult population that are both regular smokers and suffer from emphysema is 0.144%. So they gave us both. So that's your overlap, right? If you were doing a Venn diagram. So the probability of a smoker and emphysema is going to be 0.00144. Okay? All right, now let's read the last part, and let's point this out right here. They're asking, is being a smoker independent? In other words, not having any effect on whether you have emphysema. Okay, so that's what we're going to try to figure out. So I'm going to start just by using this rule. This is the rule, honestly, that we use most of the time, but I am going to tell you, we have seen this rule on the Regents. So I will use this rule with some of the other questions. So we're just going to start with this rule. And it's really pretty straightforward. Honestly, I know how you love this, but if you memorize the rules, it's really pretty easy. So I'm going to start by saying the probability of S and E, smoker and emphysema, and I'm going to see whether or not, so I'm going to put a little question mark there because I'm not sure whether this is going to be independent or not. So probability of S times the probability of E. So I'm just going to plug the numbers in. Well, I know the probability, let me just kind of section this off here. Probability of S and E is 0.00144, right? Sorry, that's really bad handwriting. And we know that the probability of S is 0.08. Oops, sorry. That's a really bad 8. And we know the probability of E is 0.018. Okay, so the rest is just math. And again, we're trying to figure out whether these are equal. So I am going to, I don't know why my little stylus here is not working, that's a question mark. See whether those are equal. All right, so I know obviously the left-hand side is 0.00144. Okay, now the right side, I'm just going to do 0.08 times 0.018 in my calculator, and I get 0.00144. So since those are equal, then I would just restate the rule. So if we look at this, so since the probability of S, sorry, I can't type the symbol, S and E equals the probability of S times the probability of E, so I'm just restating the rule here, then being a smoker is independent from having emphysema. And that's it. Alrighty, so this one's a little bit different. They want us to complete this, what they call a hypothetical 1000 table, and then determine whether the events of participating in extracurricular activities, which I'm going to label E for extracurricular activities, and know what I want to do after high school, so I'm going to put a K for know what I want to do after high school, and we want to determine whether they're independent or not. So we're going to use the rule. But before that, let's look at this table. Now listen, they're showing you right here that they call it a hypothetical 1000 table because the total here is going to be 1000. So then what I'm going to do is I'm going to look here and I'm going to say, oh, well, if this is supposed to be 1000, then I know this box is going to be 200. And if this is supposed to be 1000, then I know this box would be 400, right? All right, so let's put those in there first. So I know that I'm going to have 200 here, and I know that I'm going to have 400 here. Okay, so then I can start to fill in, and then I can say to myself, well, if this is 50 and that's 200, then this one is 150. So let's put 150 there. And then above that, I would subtract that 150 from 400, right? And that would give me 250 in this box. And then if I have 800 to the right of that as the total, and then 250, then I know this would have to be 550. So I completed my table. All right, so then it says to determine whether or not the events, extracurricular activities, and know what I want to do after high school are independent. So I'm going to state the rule. So probability of extracurricular and knowing what I want to do after high school, will it equal the probability of extracurricular times the probability of knowing what I want to do after high school? So we're going to figure that out. All right, extracurricular and knowing what I want to do after high school would be right here, right? But again, out of 1000. So that's going to be 550 over 1000. Then I'm going to do probability of extracurricular. Okay, so extracurricular, that total is right here. That's 600 out of 1000. And then knowing what I want to do after high school, follow that out, and you're going to see that that will be 800 over 1000. And again, I'm not sure, oops, that's supposed to be 1000, this is supposed to be 1000. I don't know if these are equal, so I'm going to put a question mark over my equal sign right now. Okay, so now if I were you, I would just take each of these fractions and let's convert them to decimals. So this is going to be 0.55 equals, maybe, not sure. And then 600 over 1000 is 0.6. And 800 over 1000 is 0.8. So 0.55. And let's figure that out. That would be 0.48. Oops. So no, they're not independent. Okay, so let's state that then. And then this is what I would state. Okay, now please make sure that you are taking notes in your packet for everything. So all of this should be written down. So pause me if you have to and write everything down in your notes. Okay, so this one's a little bit different. It says to complete the table below, but in a way that would indicate the two events using a computer and taking a math class are independent. Okay, so I'm going to look at it from this perspective. So if that's the case, then what I want to know is the probability of using a computer and taking a math class, and they're telling you that they will be independent. So no question mark above that equal sign. Okay, so let's see what I do know in the chart. Well, I know that this box has to be 300, right, because it's got to add up to 1,000, and I know that this one is going to be 400, and after that I'm stuck. I don't have enough stuff here. But I do know, again, that it is independent. So I don't know the probability of C and M, which is over here on the left, but I can figure out the probability of C and the probability of M because I think I have enough information there. So let's look at that. So I know that the probability of using a computer, well, that's 600, right, over 1,000. And the probability of me taking a math class is 700 over 1,000. So when I multiply those two together, I get 0.42. Now they're saying that this is an independent set of events, so that means I know the overlap has to be equal to 0.42. Now if I want to put it back in terms of my 1,000 two-way table there, I would just take this number, 0.42, right, this number, and I would multiply it by 1,000, okay? So then, if I do that, then I know the probability of C and M, which is my overlap, would be 420 if I multiply by 1,000. So then I can throw that 420 right here because there's my overlap. And now I can go through and I can subtract and find everything else. So that would make this 180. That would make this 120. And that would make this 280. Okay? And then we're done. So we're not trying to determine whether something is independent. They already gave it to us, and we're using that to find something else. All right, now, there is another option, and remember there's that other rule that I was telling you about for independence that we do see on the regions. So I'm going to show this to you. You may like it better, you may not. And again, please make sure you do know that you are writing these notes onto your packet. So here was the other rule. And remember I said to you, if you use the other rule, whatever letter comes before the given symbol is the letter that you're supposed to have over here. Okay? All right. So now, if let's start with probability of C. Well, I know the probability of C is 600, right? Over 1,000. Okay. Now, let's look at this probability of C given M. So what this is saying is, looking at the M column, or the M row. So let's go up there. M stands for math, right? So here we are right here. So out of the total number of people in a math class, which is 700, right? So out of those 700 people, okay, so given that you take a math class, out of that 700 people, how many of them are also using a computer at least 3 times a week? Well, if we go up here, right, this is my total. I mean, I do know it's 420, but I didn't in the beginning. So I didn't know what this was. So that being the case, what you can do then is say, well, I don't know what it is, so I'm going to call it X. Well, I've got a proportion here, and I can cross multiply. So X times 1,000 would be 1,000X, and 700 times 600 would be 420,000, right? And then just divide out the 1,000 and you have x equals 420. So that's another way to do it. You may like that. If you like it, use it. If you don't, don't. Make sure you take notes, okay? All right, 22. So we've got a group of high school students, right? And they're taking a standardized test, and the number of students who passed or failed the exam is broken down by gender, so male, female. All right. So what I did do is I started by adding up all the males. So I went and I added 78 and 26, and I got 104. And then I added up all the females, and I had 92. And then I did the same thing with the number of kids that passed, so that was 147. And the same thing with the number of kids that failed, so I added those guys up, and that thankfully was a smaller number of 49. Okay, so they want you to determine whether gender and passing the test are independent. So again, you're going to choose one of the two rules. Now, when it comes to gender, listen, you can pick male or female. I'm going to tell you that I did both just to check to make sure I was right. So it doesn't matter whether you pick male or female. So let's say I'm female, so I'm going to go with female. How about that? So I'm going to figure out the probability of female and passing. And I'm going to determine whether it's independent. So I'm going to put a question mark because I don't know. And then I'm going to do probability of female times probability of passing. Okay? All right, so let's look at the probability of female and passing. Well, female and passing, that's 69, right? Okay, now let me also back up for a second, and it should always be out of a total. And total would just be adding 1, 2, 3, 4, those numbers up, right? Okay, so if you add those four numbers up, you're going to get 196 total. I'll put that over here. So that's how much we have total. So when I say the probability of female and passing, that would be 69. Well, that would be 69 out of a total, though, of 196 students. All right, so then let's look at the probability of female, which is the total number of females, which would be 92 out of 196 times the probability of them passing, which would be 147 total out of the entire total, which is 196. And again, I'm not sure whether they're independent, so I'm going to put a question mark over my equal sign. All right, so I'm just going to put I'm going to just start, and I'm going to go from left to right. So I'm going to put this fraction in my calculator, get a decimal equivalent. Same thing here, and then I'm going to work it all out. All right, so 69 over 196 is 0.3520. 3520. I'm not sure, so I'm going to put a question mark over my equal sign. And 92 over 196 is 0.4690. And 147 over 196 is 0.75. So I multiply that out on the right-hand side, and on the left-hand side, obviously, I have 0.3520, and woohoo, look at what I've got here, 0.3520. So determine whether whether gender and passing the test is independent. Yes, it is independent because, and then I'll write everything down for you in just a second. But again, let's say you chose not to use female. If you used male here and male here, I worked it out, you will get the same thing. You won't get these same numbers, but you will get the same number on the left as you do on the right, and that's all that really matters. Okay? And there would be your explanation. So gender and passing the test are independent since the probability of F and P equals the probability of F times the probability of P. Make sure you're taking notes. Now, if you don't like that way, whoops, let's try another way. So remember the other rule, and perhaps maybe you would like this way better. So the other rule would be the probability of female given that they pass the test equals the probability of female. Okay, so let's look at this left-hand side. So the probability of female given that they pass the test. So what I'm doing is I'm looking at just the kids that passed the test first. So that's 147 of them. And of those 147, 69 are female. So I'm going to write that as 69 over 147 equals, and then the probability of female. Well, there are a total of 92 females over 196 students altogether. When you divide 69 divided by 147, you get 0.4694. And I should go back here. These should be question marks, right? Because I'm not sure. And then I'm going to do the same thing with 92 divided by 196. And I get the same thing, 0.4694. Okay, and then obviously you would use the same statement that I have up here. All right, so 24 Part A and Part B I think are pretty straightforward. Determine the probability that the bus is on time. So you're just going to look, and you're going to look at the total of on times. So that would be 112, right? Out of a total of 200. And determine the probability that the bus is delayed, given that it occurred in July. So we have to look at just this July row right here. So there's 79. And of those 79, what's the probability that they would be delayed? And that would be 35. So 35 out of 79. Okay, so this will be 35 over 79. Now they want to know if being delayed and the month of June are independent. So you have two choices here. Now we can use either rule. So you know what, I'm only going to show you one rule this time, and I'm going to actually show you the probability of delayed given that it's June, because that's quicker, by the way. You can use the other one, it's totally fine. Okay, so we're trying to figure out whether they're independent, so let's put that question mark above the equal sign. I'm going to do the right side first. So it says the probability that it's delayed, right? So let me get my little pointer here. Okay, delayed. So that would be 88 out of 200. So over here, I'm going to write 88 over 200. All right, next, probability of delayed given that it is June. So we are just going to be looking at this row of the June people, or June buses, I should say, really. And there's 63 total. And of those 63, what's the probability that it will be delayed? Well, there are 23 of those 63 that are delayed. So on the left-hand side here, we're going to have 23 over 63. All right, so then you just put each of these separately in your calculator. So this one over here will be 0.3651. And on the right here, I have 0.44. Well, that's not it. Okay, so then are the events being delayed and the month of June independent events? No, they're not. And there would be your statement. Again, make sure you have all this written in your notes. Okay, so last question. They want you to be given that the events A and B are independent, and then determine the probability of A and B. Well, since they ask you to determine this probability, then obviously they want you to use the first rule, which is the probability of A times the probability of B. Okay, and they're giving you that these are independent, so I'm not going to put a question mark above my equal sign there. So they told me that the probability of A is 0.85, so I'm just going to throw that right there. And then the probability of B is 0.2. Well, this is super easy, right? Okay, and again, they're telling us that these guys are independent, so no question mark above that equal sign. And what we're trying to find out is the probability of A and B. So I just simply do this in my calculator. It's 0.17, and look at that, done. All right, so this is what I want you guys to do, and the sub should already have given this to you, but your homework, I'm going to say it again, is going to be to go back to numbers 15 up to numbers 27, and you're just doing the odd numbers for homework. Okay, do not do what it says on Google Classroom. This is what you are doing for homework to the very best of your ability, and I will be checking this tomorrow, so make sure you do it. Okay?